All right, let's go ahead and get started. Thanks everybody for joining today. My name is Clay Buckle. I'm the Director of Sales with Selectus, and I'm joined by Dimitri Katsakopoulos. He is our founder and CEO. Dimitri, you want to say hello?
Hi, everyone. Thanks for joining today. Really glad that we have the opportunity to talk a little bit about Selectus and show you our platform, and excited to dive in.
Awesome. We'll start today by going through some slides, kind of level setting a little bit on data engineering and the Magpie platform. And then I'll hand the mic off to Dimitri. We'll talk a little bit about the architecture of our tool and then move into the use case itself and get eyes on Magpie. So let's start with a little bit about Selectus and what we do. At Selectus, we help companies to get more productive with their enterprise data faster. Our data engineering platform, Magpie, is what we're going to demo today, and it provides all of the data integration, data exploration, and governance tools needed to build an end-to-end big data capability in a number of weeks instead of months, which we see fairly often in the enterprise. And we'll break that down a little bit more as we dive in deeper. So what is data engineering? Data engineering is the practice of integrating and organizing data to support decision-making, putting it simply. And some of the pieces that are necessary for advanced data engineering include data integration, exploratory analysis, collaboration, infrastructure pieces, governance, security, and these toolings together allow you to be able to organize and analyze your data in a way that can provide more succinct insights and quicker results.
Yeah, just to dwell on that slide for 1 second, I have a couple of things to add.
Sure.
I think the way to kind of think about this and the way that we think about it, and this is kind of reflected in the platform, is that you need to take a holistic approach to data engineering. Rather than doing each of these things piecemeal, being able to do them in an integrated way, being able to do them in a way that sort of acknowledges how they play into one another is really important. And that's kind of the philosophy that informs the way that we've built out the product.
So a little bit about why data engineering is important. First, it's foundational, right? In order to get better analysis and to move into kind of the data science area, what you need is that foundation of engineered data. And the other piece is data engineering impacts everyone. There's end users in IT, business leadership, and analysts in data science that are looking towards building models and getting insights, and having the data in a format to be able to analyze and iterate the data is important, and that's where data engineering comes in. So this is where Magpie, our platform, comes in. We've built the platform with a full cycle of data integration features for management as well as analysis. So Magpie includes the ability to organize your data, integrate from a number of different sources, build repeatable pipelines, and connect to on-premise and cloud data sources. Within the platform itself, you'll be able to do some discovery, build some automation, understand more about what's going on with your data, collaborate, and add machine learning and AI libraries. And then we also include the ability to govern and manage and scale. So I think the big thing about this slide is that Magpie is a complete platform. We offer kind of an out-of-the-box data engineer's operating system that gives you all the ability to do really everything that is necessary for advanced data engineering, for things like building data lakes and performing advanced analysis. I like this slide because it shows a little bit about kind of the infrastructure that we see in some large enterprises, and this likely relates to a lot of the attendees in terms of your understanding of building an advanced infrastructure like this. To the left, traditionally, people would, decide on some sort of an architecture. They've got to, hire a large team, choose which cloud they want to go to, do a lot of things that take a lot of time and a lot of money. And what we've done with Magpie is provided an out-of-the-box platform and infrastructure so that you don't have to spend quite as much time in making a lot of these decisions, so that you can start getting insights quicker and your time to value is brought down. A little bit about the Magpie advantage. So we're built to simplify the complex. Magpie is a cloud-based tool. There's no heavy install. You log in once your cluster is running and you can get started. There's really no new tool to learn. There's not a lot of proprietary drag and drop or menus to learn. In Magpie, we leverage things that data engineers generally know, which includes SQL and programming language like Python and R. Again, kind of in the theme of centralization and unification, we include all the pieces you need for profiling, for metadata management, security and governance, and centralizing the scheduling as well as the orchestration gives you the ability to not have to toggle between tools and stay within Magpie as you're discovering, iterating, and then moving into production. We oftentimes see a number of different use cases, but we help to enable replacements of homegrown solutions and older legacy client server solutions. We help teams to quickly advance into kind of the big data and Spark area confidently, again, without the large infrastructure burden and risk that we've seen in the market. And then we help you move into more modern concepts like data lakes and AI and ML and enable data science teams to be a little bit more efficient and nimble. And then we also see on a project basis or maybe even a department specific basis, they need something like what we provide or a data engineering capability, but sometimes they're limited by tool set or maybe budget. And Magpie can help to get that buy-in and get them the data engineering platform that they need and really get them the insights that they need. A little bit about our architecture. Dimitri, I'll hand the mic over here and you can break this down from a technical perspective, and then we'll get to the demo just after.
Yeah, so this will help kind of orient you around the demo, hopefully, and kind of the context. So this is our architecture. A few things that I would point out is at the top layer, we've got the sort of the ways that you can interact with the platform. We have our notebook, and inside of our notebook, we support SQL, R, Python, Scala, kind of as Clay mentioned. We also have our own domain-specific language, and that's the thing that allows you to kind of configure the platform, do things like run profiling, integrate new data. That DSL allows us then to also give you a command line interface. So you've got this ability to go from notebook to command line, integrate with external tools, external orchestration tools, things like Airflow if you want to do that, integrate with CI, CD. So if you're using something like Jenkins or Circle CI, you can integrate with that as well. And then finally, you can integrate with the sort of range of business intelligence tools that you're used to. And from the outside in, Magpie essentially looks like a database. So again, there are a lot of ways to interact with the platform, the notebook being sort of the way to interactively build pipelines, prototype, explore the data as you're trying to understand the right way to shape it. Sitting in the middle is that management layer. And that's where, those services that Clay mentioned live. That's where the catalog, security, kind of pipeline building, scheduling, they all live there. And that's kind of powered by our metadata repository. And that metadata repository is really what allows us to do things like track profiles, track all the usage of the data, do things like understand lineage. Sitting underneath that is Apache Spark. And, we've kind of mentioned Spark a couple of times. One of the advantages of the platform is that you get the scalability of Spark. You're able to access that Spark layer directly if you want to, and use things like the Spark ML libraries, but you're not sort of constrained by the heavy technical lift that it takes to get Spark up and running and to operationalize it. Underneath that, just range of different data sources. And worth mentioning, we're deployed across all three of the major cloud providers. So we've got customers live on AWS, Azure, and Google Cloud. All right. So a little bit of context around the demo. For today's demo, let's imagine that we're at a real estate company and we're trying to do site selection for a new hotel. We've got some data sources, some public data sources that we've discovered that we can use. We've got some, sort of structured data coming from Airbnb that's living in an Amazon Redshift database. You can think of that as a proxy for any relational database. We've got data from the New York City Taxi and Limousine Commission that can give us a sense of what traffic looks like, kind of what are the busy areas where we might want to build that hotel. We've got data from the New York City Department of Finance that tells us about tax, essentially property value assessments. It's not exactly market value, but it's a pretty reasonable proxy for it. And then we've got some data from the New York City Department of Buildings. And what we're going to do during the course of this demo is we're going to go through a kind of rapid analysis where we're going to build out essentially a mini data lake and do some analysis that spans those different sources that we've kind of laid out. We're going to build a pipeline, and it'll be a simple pipeline, but it'll demonstrate, once that pipeline is built, how do we report on its execution, and what does that typically look like inside of the platform. And then finally, we'll demonstrate some of the security and governance features with a particular focus on, how do you do access control inside of the platform, and then how do you do activity tracking? What does that activity tracking look like? So that's really it. And with that, I'll switch to sharing my screen, and we can dive into the demo.
Awesome. And as Dimitri starts to share a little bit of housekeeping, if there are any questions or comments as we're going through, either based on what we shared from a PowerPoint or from what Dimitri is going to share, please use the Q&A option, and we will get to those near the end of our time here. Take it away, Dimitri.
Okay. So what you're seeing here is that notebook interface that I mentioned. It probably looks familiar to some of you who've used things like Jupyter or Zeppelin in the past. You're able to kind of integrate markdown blocks to annotate the data. And in this very first paragraph here, what you'll see is this create data source command. And that's a command in our domain specific language. We're basically telling it about an endpoint, giving it some credentials, and creating a data source. That data source is something that now exists in our metadata repository. And so, your end users, let's say that this is an administrator that's doing this, end users don't need to know about that data source. The next step, now that we know where that data source is let's figure out what the data is. And now what we're doing is we're creating a schema inside of Magpie that represents the data that's contained in that database. And this is using, again, our DSL. We're just creating a schema from this data source. So let's just run that. And what that's done is it's really grabbed 6 tables. There aren't very many. And what we can do after that is we can profile the schema. I'm not going to do that right now because it takes about a minute to run. But what we're doing is we're really quickly gathering some intelligence about the tables that reside in that schema. And what we can see here is there are 6 tables. We get field counts, we get row counts, we get earliest and latest timestamp if they happen to have a timestamp field. And this is kind of interesting when you have 6 tables, but it's not atypical to have hundreds of tables in a single schema. And that's when this can become really useful. It kind of helps maybe separate the wheat from the chaff a little bit in terms of tables that are maybe temp tables that weren't ever deleted, or things that haven't been updated in a very long time. You sort of very quickly get a sense of what you need. In this case, we're very interested in the listings table because that's going to give us a sense of, hey, is this kind of what we're looking for? And can we get a sense of what the pricing is, for example, for a night's stay in a particular area of the city? And so now what that's doing is we haven't moved any data. This is just reaching back into that Redshift database and grabbing a set of rows that we can then look at. And what we can see is this, this looks kind of like what we would expect, right? It's got the kind of core descriptive information about the property. It's got the URL for the actual listing on Airbnb. And so, at first glance, this looks like what we're looking for, and we can kind of move on to the next step. In a minute, I'll show you a little bit more of what we can do at the table level to profile data and get even more intelligence out of it. But for now, we're just doing this quick sampling, like, hey, let's just look at a few rows. Now I'm creating another data source. And in this case, the source is actually an S3 bucket. So S3, for those of you who don't live in the AWS world, is essentially a distributed file store, distributed object store that looks very much like a file system, particularly to tools like ours. And what we're doing now is we're saying, okay, let's use this new schema we just created, and let's create some tables from the files that live in that repository. So now we're not using a database anymore. We're just using a set of files, and we're creating tables out of those files. And those tables look within the Magpie environment like any other table would look. We can also profile tables. Again, I'm not going to run this interactively because it takes a few minutes to run. But what we can see here is we've got 100 million rows. We've got some fields that we can look at. So for example, we've got vendor ID. And if we pop that open, what we can see is that we have a readout of how many null values there are. And in this case, we don't have any nulls. So this is probably a pretty good data set. We can see how many distinct values there are. It's not very distinct. It only really takes on 3 different values. And we can see the top N here. Typically it's top 10, but this only has 3 values. So that's interesting. It's a way to understand what's in that column. If we take a timestamp, we can get even into more depth. So here what we're seeing again is this is 100% populated. So that's a great thing. We can see that it takes on some more distinct values. And you know, the top 10 isn't that interesting because this is a pretty flatly distributed set of data. But what we can see here is because this is a timestamp, we can actually lay that out on a timeline and kind of understand what the distribution of the data is across date, across year, across month of year. We can start to look at this and say, okay, well, there is some seasonality here, right? It looks like people are taking cabs more frequently in the spring and in the fall. We can see over the course of a day that traffic builds up toward the start of the workday, is pretty busy throughout the day, peaks at about 6 p.m. when folks start going home, and then gradually declines into the evening. And again, kind of what we would expect. Something like trip distance, which is a numerical variable, here what we can see again, you know, distribution of values is not that interesting because it's not very spiky, but we can build a histogram. And now we can see, okay, this data is really distributed the way that we would expect it to be distributed for something that's kind of bounded by 0 on one end and has kind of this long tail of further distances, with a lot of the taxi rides kind of concentrated in that range of, you know, a couple of miles. We also see these peaks at kind of even intervals, which makes me think that there is maybe some rounding going on. And that's something, you know, that again, now that I know that, I could look into it and kind of understand what the underlying dynamic is. And then we've got some descriptive statistics as well. A couple of things to know about these. This is just a one-liner. This kind of analysis is sort of built into the platform. So you just run this profile command and it will generate the profile against any table. And then once that profile is generated, if I go in and I describe that table, that profile is available as a tab in this description view, and it contains all that same information. So, you know, again, it's not just that we're able to get this intelligence sort of in one shot. It then becomes a shared resource that everyone has access to. Now that we've got our data staged, what we can do is we can actually run a query that spans those 2 data sets. So we haven't moved any data. That data that was in S3 still resides in S3. We still have data in Redshift, and we're able to do this federated query that spans both of those. Now, running that query, you know, we can start to think about how does the cost of an overnight stay and the number of listings relate to how busy an area is, for example. And so in this case, we're plotting the total number of taxi drop-offs on the y-axis against the average listed price for those Airbnb stays. And what we're seeing is a little bit of a diagonal. They're correlated kind of as one might expect. We're seeing maybe some interesting properties in this $200 to $250 range. We can actually go ahead and throw this onto a map because it's got some lat long data in it. And then we can do things like look at coloring, for example, by let's say the average listed price. And we can do the radius here based on the total number of taxi drop-offs, for example. And you see a pattern here that looks a lot like what you'd expect in a city like New York, which is the sort of city center in Manhattan is pretty dense, and the kind of cost of an overnight stay is higher. And as you go to the outer boroughs, you see kind of it starts to decline as you get further out. We might be interested, for example, in this Murray Hill neighborhood because it looks like there is a lot of taxi traffic there, and it's sort of in a sweet spot from a pricing perspective, sitting between $200 and $250. And so what we can do is we can jump in and we can grab some data to let us now that we know we've got this sort of broad area that we're targeting, we can grab some data. And this is data from the New York City Department of Finance. It's essentially property tax assessment data. And we're just grabbing it from URL. So this save URL as table is an example of another sort of command that exists in that domain specific language that we've created that lets you do this in a pretty convenient way. When you start thinking about building pipelines inside of Magpie, all of these steps that I'm taking, you could kind of chain them together into a pipeline. And so it's, let me get data from the source, let me profile that data, maybe let me integrate some third-party data that I know is out there on the web and profile that as well. And then let me build my analysis on top of that. So, all of these commands in the DSL, as well as SQL queries, as well as Python scripts, can be integrated into jobs. And you'll see a little bit of that in the next step. Now that I've got this table, I can go ahead and describe it. And what we can see here, if I search on my columns, is we've got the assessed total, which we're interested in. How much are the properties worth? And then we might want to look at, let's say, the lot area, so that we know how big the property is. And then all we're doing here is running a query against this new table that we've just created to grab properties with a lot area of more than 10,000 square feet that are assessed at less than $20 million. And what we find here is there are about 37 properties. Some of them are already hotels. Kind of glancing through this, there are a couple of condo buildings, there are a couple of libraries, there are some churches. It's sort of what you'd expect in terms of properties with that footprint in that neighborhood in New York. So now that we've got our list of target properties, maybe we want to save that off, and we can just save that result as a table. And we can also then export that result and essentially download it as a CSV file.
And this, what you've shared, Dimitri, is all in kind of the discovery, build the analysis phase. Is that a good way to describe it?
It is. I mean, the way that I would think about this, from a practitioner's perspective, right, for data engineers, it's, this is sort of that early step where you're trying to figure out what the data content is and sort of roughly by hand, figuring out what that data flow needs to look like.
Yep.
And once you've kind of figured that out, you can take these little chunks that you're building in paragraphs and you can kind of string them together into a pipeline, knowing that there's always, the hard work of refining the data, thinking about what the right target structure is and all of that. But this is this should feel familiar, I think, to folks who have to, build pipelines for data. When you first get that new data set, kind of understanding what's in it.
Got it.
Now what we're going to do is we're going to build a job. And the way that jobs work in Magpie is they consist of tasks, and those tasks have dependencies. And so you build a kind of a dependency graph. It's very similar to what you might see in something like Apache Airflow, for example. It's a very natural way of doing this. So a lot of tools kind of converge on that. If you look at this, what we're doing is we're creating a job and then we're populating it with a couple of tasks. So, here we're creating the job, we're giving it a name, we're giving it a description. Now we're creating a task, and in that task, we're just applying a script. So this is a script in that DSL that we've created. In this case, what we're doing is we're actually saving all of the building permit data for the city of New York for this year. That takes about 10 minutes to run because it's a fairly large file that gets downloaded from this website. And so, we want to schedule that because we don't want to wait around 10 minutes every time we want to see that data. We just want to have the current day's data available to us. And then after that, what we're doing is we're altering that job again. We're adding another task. And in this case, we're adding another profile task, essentially, to profile that building permits table that we just created. You can create tasks in SQL, essentially just SQL mappings that produce a new object that then gets saved as a table. You can run arbitrary Python code or Scala or R code in the context of a task, or you can run anything in our domain-specific language. In this case, we're just chaining together two commands in our domain-specific language. You can also then take these jobs that you've created and nest them as tasks within other jobs. So that's how you can start to build some hierarchy and have a little bit of kind of modularity in the way that you build jobs. We can execute that job interactively. Like I said, I'm not going to do that right now because it takes about 10 minutes to run. We can create a schedule around it. In this case, we're just using this kind of cron style notation to say, okay, we want this to run at 11 a.m. UTC every day. We want to get a notification if the job fails. You can get notifications for failure, for success, as well as you can embed within jobs assertions where you're checking values or checking query results that will then also notify if there's an issue. Now that we've built this job out, we can describe it. And what we can see here is we've created these two steps. We know that this step has one successor. We can look at the schedules that we've created and we can see that, yep, it's set to run at 11 a.m. This lineage tab that's also available with all the objects. In the case of this job, it just gives you a history of all of the changes that have been made to the job structure. Now we can look at the execution history of the job, and this is something that we've scheduled to run every day. And what we can see is that, yes, it ran this morning, and it looks like it succeeded, and it ran in, as usual, about 10 minutes. And you can see the individual steps. If there are errors, you can get the stack output, stack trace output, or other error messaging sort of embedded here. But you have a pretty complete ability to schedule and run pipelines in this way. So that's kind of a very high level view of how pipelines get built. This next piece, we're going to focus in on a couple of the governance functions really around security and essentially audit logging. First thing we're going to do is, typical scenario, you might have an analytics team that you want to give, you want to then have access to your data lake, right, to this environment that you're building up inside of Magpie. You can create a workspace for them. And so we're just creating a schema here for the analysis team. And then we're creating a role that we can assign to people. We're giving that role read access on the two schemas that we've been working with because we don't want anyone to change those. We sort of consider those the gold copy of that data. But then we allow them to do create on their own schema. And then we can grant that role to a user. It's a very database-like model for doing access control. And so it should feel familiar to folks that are coming from the database world. And it really does ease, sort of the complexity of maybe granting permissions across multiple tools that folks might need to use. All of the sort of levers that you need to control access to the data, control access to jobs, control job execution, sort of lives in this one place, and the same security model gets applied to all of them. So you kind of define your roles once and you can apply them across the platform. Now that we've created this role, we can describe it. And we can see that, yep, we've got one member that we just assigned. We've got read access to the two schemas that we created earlier. And then we've got create access to this new schema that we've created. So those folks can go ahead, write their own queries and execute them in the environment. Finally, here's a view of the activity history. And here what I'm doing is I'm just looking at activity history for the Selectus organization itself in this demo instance. And what you can see is a listing of, here are all the things that I've been doing throughout the demo, really. So for example, I ran that query earlier that was spanning Redshift and the S3 environment. And you can see not only do I get the query and I know who ran the query, you also get to see what were all the permissions that were invoked in executing that query. And that's where sort of the integration of the security model gets interesting. We now know that, yeah, we have a way essentially of auditing not only which user did what, but also how did they do it? How was I able to do it? Well, it looks like it is because I have I have read access on this set of schemas and tables. I have use access on these data sources, and that's kind of what enabled me to do that, to do those specific actions. We can also obviously do that at the individual user level. So we can do activity history for an individual user, and we can do usage history on an object. So in this case, we're just looking at what have I done inside of this data source. And we can see that, we had the kind of initial creation at the very beginning at the very beginning of the demo. And we can also see where this was used when I was executing that query earlier. So again, you get this kind of, you get a fairly deep ability to explore the data, to build out your pipelines and sort of administer them. And you're getting this overlay of security and governance capability that is really useful as you think about, okay, well, how do I scale this across a team? How do I scale it inside of an enterprise? And this is how, you support kind of dozens or hundreds of users as opposed to, having this be sort of a desktop capability for one person. So that's sort of the full scope of the demo. Hopefully that provides all of you with a broad sense of all the things that are kind of built into the platform, all the capabilities. If there are any questions, definitely feel free to kind of raise your hand. Clay, I don't know if you're seeing anything from anyone in terms of questions.
1 second, let me check. Good job, Dimitri. I appreciate you doing that. I'm just jumping back to the slides here. Okay. Any questions from the audience? Does anybody have, we got one pop up. We have one question. Who's the typical end user of this tool? A data analyst, engineer, or scientist?
Yeah.
You want to take that?
Yeah. So what we typically see inside of the customers, almost always a community of users that we have are the data engineers. And they're using it to, again, build out pipelines, do that initial data exploration so that, as new data comes in, they're able to go back, for example, to the app development team and say, hey, this doesn't look the way that it should. It lets them, sort of do that first pass quality check and then build pipelines, schedule them, and kind of execute them ongoing. One of the surprising things that we've seen at customers is a lot of analysts tend to use the tool, particularly at a couple of customers. We have analysts in the lines of business that are sort of SQL conversant, and they tend to like the tool because it gives them a window into the environment that's richer, with things like profiling and with even just the ability to build notebooks, than what you might get out of something like a SQL workbench or just an end user SQL client, without some of the overhead, for example, of using one of the kind of drag and drop BI tools, where if you're very sort of conversant in the data, it's oftentimes feels better to just be able to write queries than to have to put together kind of a full-blown dashboard to get at the intelligence that you want.
That makes sense. Another question: can Magpie connect to applications like Salesforce and NetSuite, and then also Snowflake as well? There was a query about that. So Dimitri, is that something that Magpie can do as well?
Yeah, so I'll talk about Snowflake first. So we can connect to just about any JDBC source. In particular with Snowflake and with some of the more predominant analytics databases, we have named connectors. So for Snowflake, there is a kind of faster path in Spark to accessing data within Snowflake, and we fully take advantage of that rather than just treating Snowflake like a generic JDBC connection. With respect to APIs, we've definitely done kind of Salesforce integration with the Salesforce API inside of customer environments. The way that typically people do that is by I mentioned, but I didn't demo, our sort of channel into Python. But just about any API out there that you can read using Python, for example, you can get to inside of Magpie. Or if there's a like an SDK in Java, you can integrate that, for example, through our Scala layer. So generally, we can get into APIs. We don't have again sort of the named connector for Salesforce yet, but that's something that we're looking toward in the future.
Got it.
And we've definitely the Salesforce integration into Magpie has been done and has been done in sort of at scale.
Yep, that makes sense. And last question, you mentioned lineage at least partially. Is that something that's being built up in the tool? And it seems like the catalog on the back end is really, we'll say, enabling there. Can you speak to that a little bit?
Yeah. So with respect to lineage, we are just about ready, probably this week or next week, on our next deployment, to release a more full-fledged lineage feature for data that actually shows the kind of dependency graph from current table to all of its upstream data sources. Right now, what we have in the tool that's deployed live currently is a lineage that shows in a narrower way just what are all the actions that were taken to create this particular object or to update it. And so, kind of watch this space with respect to that kind of richer lineage. And it is literally, like a week or two away. So that's actually a feature that we're really excited about, and we'll probably be talking about over the course of the next couple of weeks.
I can imagine. So I've heard some, we'll say, difficulties around Spark and being able to get lineage. So definitely looking forward to that. Trying to see if there's any other questions. Give me just 1 second. I don't see anything else. I think, one more question. What kind of Spark skills or background, given the infrastructure side that we're leveraging from a power perspective, what does somebody need to understand in order to kind of, I don't know, operate, maintain something like this? Do you have to have a background with Spark, or what's really the I don't know, operational needs for Magpie?
Yeah, the platform sort of takes away a lot of the operational complexity. What we've seen really succeed with customers is having a community of users that are, kind of fluent in SQL. That tends to be sort of table stakes.
Yep.
The nice part there is that's not a rare skill set. And then a little bit of Python is also really helpful because that lets you do, kind of expands the range of things that you can do with the platform a little bit. But you don't have to be knowledgeable about Spark to get started. Some of our customers, as they've kind of used the platform over the course of the last year or two, they've gotten more sophisticated. And once you start getting deeper into it, that Spark knowledge starts to accumulate kind of naturally within the team. And it helps from a sort of tuning and troubleshooting perspective. We're there to back up our customers with that deeper expertise if need be. But for most routine deployments, you can be very productive without having to dive too deep into the Spark layer.
Got it. Great. Let me just double check. Looks like we might have gotten one.
Yeah, it looks like I'm seeing one question. How are you seeing companies try to quantify ROI for adopting Selectus? That's a great question. So we've seen a couple of different patterns there. One thing that we've seen is there is kind of an economic argument that you can make just in terms of cost avoidance, particularly if you're in an environment where you're using maybe a more traditional kind of client server tool that's got kind of a heavy licensing cost associated with it, something like maybe an Informatica. There's sort of a cost argument to be made there. We've had customers sort of talk about the way that they are avoiding adding nodes to their Redshift environment by creating essentially kind of a release valve for a lot of the bulk analysis that they can do in a more ad hoc way within Magpie, rather than having to push all of that into the warehouse. The other place where we see ROI coming through is around productivity, essentially, and it is hey, this is keeping me from having to hire an additional person.
Yep.
Because this process that we were running internally was really challenging us, or because this tool set that we're using right now requires, expertise and a level of attention that we just don't have available within the organization.
Sure.
So that sort of, hey, we're avoiding the cost of adding resources that are potentially expensive resources who are sophisticated about a particular piece of technology. Or the other side of it is, hey, we can redirect our folks so they're spending less time worrying about sort of a very touchy infrastructure. Yep. And more time doing the sort of value-added activity. So that's sort of the nature of ROI discussion that we tend to see.
Yep, and I can imagine there's some likely savings if someone was looking at building a stack with, I don't know, your common governance tools and adding catalog and getting some sort of traditional data integration piece as well. This really meets the need.
Yeah, I think that's a good point. There's kind of, we have taken this holistic approach. And what that means is that if you're trying to get out of the gates quickly and you don't want to introduce a lot of complexity into the environment by adopting a standalone catalog, a standalone sort of management layer, a standalone orchestration layer, this can be cost saving in that way as well. And it's the classic discussion around kind of best of breed versus an integrated solution.
Yep.
Not right for everyone, but right for an awful lot of people.
Yep. I certainly hear that. Double check one more time for more questions, but it looks like, yep, we do not have any more. Wait, oh, nope, that's been answered. Great. Well, thanks, Dimitri, for answering those questions. Thank you for taking the time to do the demo. I think this was very informative. Quick note on some resources here as far as next steps. If anyone's interested, we've got a few different areas where you can learn more about our tool. First, there's our 14-day free trial. We've also got a white paper that kind of breaks down a little bit about the case for a holistic data engineering platform, talks a little bit about the things that we shared today, and breaks down a little bit more about the tool space in the market. So I'd love to share that if anyone's interested in checking that out. Additionally, we've got our documentation, which is really quite thorough and will provide kind of a leg up if you're looking towards doing something with Magpie in the near future, or want to kind of have that coupled with your 14-day free trial. Happy to provide that as well. And then finally, we've got our blog where we've got some success stories, trends we see in the market, and we talk a little bit about the data engineering space and what we think is kind of cool. So I think with that is all we've got for now. If there is any follow-up, please feel free to reach out to me directly. I think most of you probably have my email, and I'll be in touch with some of you, and looking forward to kind of breaking it down. We'd be happy to roll our sleeves up and do something custom based on your use case and trying to meet your goals for this year as well as in 2021. So Dimitri, thanks again. And I think that culminates our demo today.
Yeah, thanks a lot, everyone. Thanks for joining. And yeah, feel free to reach out. We're pretty easy to find. So hopefully we'll hear from you.
Thanks. All right, everybody. Have a great week. Appreciate you.